Welcome to the BhamQuants lecture on SQL. All right, so let me pull up my PowerPoint presentation here real quick. This is what we're going to talk about, and so I want to point out the go-to link right here, BhamQuants lectures files, which have all this information. In addition, the SQL that I'm going to create today, roughly speaking, I'm going to load up there in the next few days here. So if you want to see what I wrote, it'll be there. Also, the data that we're going to look at inside this database is inside of this file right here. And so if you wish to look at that, I'm sorry, that's not correct. It's not inside that file. If you go to the website, it'll tell you how to get the database stuff. It comes over in CSV files, which you can then upload into a database, or if you're masochistic, you can throw it into Excel and do it the hard way. But if you want to get to that kind of data, it is on the website, at this address, and you can play with that. These are topics we're going to talk about. What is a relational database? So a database holds data. So there's lots of data out there. There's Excel workbooks, there's web pages. These are individual items. So this workbook, generally speaking, does not talk to this other workbook. They're completely independent. They just hold data. So a relational database means the data that it holds connects to itself. And a good example of this is a customer relationship management software. So in a CRM, you would have a customer's name. In another place, you would have their address, their sales history, their communication history. This isn't a single row in an Excel file. These are separate tables. Each one is a different table. And because it's in a relational database, all of those tables connect together. So that's what a relational database does, is it takes these individual pieces and puts them together. So here's an example of a relational database. I have two tables in my database here. I have an owner table and a renter table. These are houses. Of course, that's all made up stuff. So in the owner table, I have an address and I have who owns the property. And in the renter table, I have the address and who is renting the property. So it's two different tables, but clearly those tables in some sort of way are related to each other. So that is a relational database that is holding two tables. So there's what is known as a RDBMS, Relational Database Management System. And these are the terms you're going to start to have heard many times. Oracle. Oracle is an RDBMS. So that is the bigger overarching thing that holds the databases, that holds the tables that are all related and all that kind of stuff. And so Oracle, as it turns out, is the #1 RDBMS out there, followed very closely by MySQL, which one of our regular members uses MySQL a lot. That's his business, is tuning MySQL. And then there's SQL Server in third place, which is my bread and butter. And IBM DB2 at position 6, which used to be my bread and butter. And then Chris Hickman, who is another regular here, I was going to rub him a little bit because SAP HANA is in position 21. There's quite a number of other RDBMSs out there, but this is just kind of the top little grouping. So these things basically, at the same time, they do the exact same thing and they do the exact opposite thing. What we're going to look at is going into the tables and querying, working around with that data in those relationships. Every RDBMS does the same thing. It does it the same way. The code you use is slightly different. You'll type in your typical SQL Server method of doing it, it'll error. You change it from a singular to a plural, it'll run. So there's different words, different methods of doing it, but it's basically the exact same thing. At the same time, they do absolutely opposite things. Oracle is designed to manage your entire company, all of it. It manages your customer database, it manages your production systems, it manages your sales, it does it all. SQL Server doesn't do any of that. The only thing SQL Server does is holds those tables together. Well, Oracle does it by creating those tables and giving you an interface to interact with the tables. SQL Server has the tables, but doesn't give you the interface. So what we're going to look at today, all the RDBMSs are the same, but on the bigger scheme, there's reasons why you would prefer Oracle versus something else. So Oracle is going to be huge because it manages everything inside your business. Right. And the only catch is it's expensive to buy, and it's expensive to maintain. And so there's a dollar threshold where it just doesn't make sense. If you're below $100 million, do you need Oracle? Maybe, maybe not. You know, but $100 million is a lot of money. MySQL is free, and so people like to use that a lot. SQL Server is a lesser cost. Like, it's a little bit complicated how much it costs, but it's lesser. Well, on the other hand, it's not going to run your business. And then after that, you have the issue of you have the dominant players who have the resources to build up their software, then you have the small players. So that's why there's a huge drop. I was actually surprised to see this, to be honest. I thought SQL Server would win, but it obviously didn't. And I was shocked to find MySQL at position 2. I would have guessed that at like 7 or 8, but those are the numbers I found, so I can't argue it. So where can you go to get an RDBMS? So there are cloud options, such as Amazon Web Services, which is what you two are connected to right now. It's an AWS server. There's Azure, which is a Microsoft server option. There's Google Cloud. There are many other cloud-based services that are out there. As a side note, I have now spun up servers inside of AWS and inside of Azure. I found Azure to be 10 times easier than AWS. I tried to do some research into the difference between the two of them. There are differences, and it is well beyond my knowledge and my skill set to tell you why you should go with one or the other. For the purposes of what we're doing today of playing with databases, for my purposes of analyzing data, Azure was easier than AWS. The reason you may want to go with a cloud-based option, super simple. In Azure, I went from I've never used it to I had a server in 30 minutes. That's how long it takes. At your company, it'll take a week because you have to buy hardware and stuff like that. The other very logical place where I highly recommend after today's meeting you go and do is talk to your company. Basically, every company has a server out there doing one of these functions. Very possibly SQL Server because they don't have money and don't want to deal with it. Being in distribution, you guys probably have Oracle. You have DB2, fantastic, fantastic. Even more expensive to maintain than Oracle. Also very, very powerful. I used to work at DB2. It's a great piece of software. Talk to your IT department. They have a server, and you can tap into it. They may not want you to. There may be a battle there, but you do have a server out there. You can, if you wish, put a server on your computer. So I have this laptop up here I'm lecturing from. I could put a server on this laptop, and I can connect to that server. Now, the reason I don't particularly recommend that you do that is that means that you have to do the maintenance of that. Most importantly is the security patches. And so people attack these servers all the time. Your server will get compromised, and it will be a problem. Also, if you do something silly like turn your computer off or undock it and take it home or something like that, it shuts down your server. And so if someone else is trying to connect to that, it doesn't work. So I have launched servers on my own laptop before. There is some advantage. It's certainly not ideal, but you can do it. So today we're going to look at SQL Server Management Studio, also known as SSMS. And there's also, you also hear the term SSRS, SQL Server Reporting Studio. That is not my bread and butter. But SSMS is how you interact with the data. It's used to connect to a SQL Server. So what about Oracle? How can you connect to Oracle through SSMS? Well, the way you do that, SSMS will connect to the Microsoft SQL Server. You then have your Oracle server elsewhere. On the Oracle server, you can put a little piece of code that says, I want you to talk to my Microsoft server. And then through that code, you can connect to SSMS. So you can use SSMS for the other database management systems. You just have to configure them correctly. Said another way, ask your IT department for help. Alternatively, so we're doing SSMS here. Oracle's standard piece of software is called Toad. It's going to be very similar to SSMS, same idea. The other database management systems, they have their own interface. So there's plenty of options, but I'm going to be teaching SQL Server. Also, let me mention one last thing real quick here. There is a difference between a server and SSMS. So a server, SQL Server, is where you put your data. It's very large, many gigabytes, terabytes, whatever. That's where all your data is. SQL Server Management Studio is how you interact with that data. So if you want to launch your own server, you need two pieces of software. You need SQL Server, and you need SQL Server Management Studio. So it's two pieces. Felt like a fool the first time I had to figure that out. Okay. So let's play around. So here we are in SQL Server. I have a couple people following along live. So we're going to fumble through this a little bit here. So here on the left side, the Object Explorer, we have the server named. Okay. And so within that server are databases. And the database we're going to work with today is BhamQuants. I'm going to open that guy. Within BhamQuants, we're going to talk about the tables. And these are the 4 tables that are here. Now real quick, up here in the upper left, so when I click on the right-hand side where I'm going to write my code, I have to pick which database I'm going to work on. Over here in the upper left, I have picked the BhamQuants database. So if you're not on BhamQuants, you'll want to switch that. I have this white space on the right where I'm going to write my code. If you need some more white space, you can press New Query, and it will give you more. Let's close that down. So we've navigated from the server to the database to the tables. And so let's look at this table called deaths. We're going to open this up. So a table is composed of columns. So let's look at the columns. And here are the columns that are inside this table. And you can think of this as an Excel spreadsheet. These are the columns in that spreadsheet. I haven't shown you the rows yet. We don't know what the data looks like, but these are your column headers. So a column header of provider ID, of hospital name, and so forth. Now these happen to be all labeled as in varchar. That means that these are text strings. So we're going to get a little bit later into the difference between a text string and a number. It's not particularly hard. You can't add text. You can add numbers. But we'll talk about some of the differences between those. And the reason I'm pointing that out is if after this lecture you go in and you want to start to mess with this thing, and you try to sum a column, and you say, well, I should be able to sum the zip code column. That's a number. Well, if we look at the zip code right here, it is not a number. It is in varchar 5. It is a text string of length 5. You cannot sum a text string. I don't care what it looks like. I don't care that it's 1, 2, 3, 4, 5. It is text. It is not a number. Okay. So I rarely actually look at my columns. And the reason I rarely do is because it's easier to write the code. So basic SQL statements are select, from, and where. So we're going to do a select star from dbo.deaths. I got a little fast there. Let's stop that. A little bit fast. Okay, I've written some code, so I want to execute that code. So right here is the word execute. I can press that. It'll execute my code. Now, in the lower left, the query is currently executing. This is kind of slow. I'm kind of tired of looking at this. I don't want to do it anymore. So I want to stop the execution. That's the square box right here. I stopped it. So what's going to happen is you expect it to return I don't know, 365 rows of data, one per day. And it gets up to 200,000 and you realize you've made a mistake. So you hit the stop button so it will stop doing this. Now realize we're talking about huge amounts of data. Now these aren't too bad. These tables are a couple hundred megabytes, but you can have gigabyte, terabyte, petabyte tables. And so it's doing this transaction from your server to your computer, and it's just slowing everything down. So hit the stop button because you've made a mistake. So you can press execute. The other thing you can do is press F5. That's the quick way. That's what I'm going to be doing here today, because once you figure out F5, you stop using the execute button. So let's look at this. Over here on the columns of the death table, I have provider ID. In my data reset, I have provider ID. Hospital name, address, address. And this is why I kind of never really look at these columns anymore. It's because if you just do a select star from whatever, then you can see all the data. Not only can I see the column headers, but I can see what the data is actually returning. So I get a feel for what I'm looking at. Okay. So this table has a couple 100,000 rows in it. It's more than I want to deal with. So let's change our query. We're going to change this to select top 100. So it's going to give me the first 100 records, F5. In the lower right, I see that it returned 100 records. This is my most common query. I cannot tell you how many thousands of times I have written this query. Just give me 100 records. Let me look at it. Let me decide what I want to do. I'm going to switch it from deaths to hospitals. Where did I get that from? Came from right here, table, hospitals. So here's the hospital table. Let's look at the hospital table. By the way, this is all real data. I downloaded it from CMS Centers for Medicare and Medicaid Services. And so we're going to look at some of this stuff. It is real. We're going to make certain opinions and observations about certain hospitals. It's all real. I'll probably put in some commentary since I work in healthcare, and we'll tell you why a lot of what we're seeing is alarming or not alarming in some form. Okay, so look at this hospital table. We're defining the hospital, say straight, state, zip, phone number, whatever. I apologize. There is someone at the door, if someone could grab that. Thank you. So we're defining that. This is a government-owned hospital or not. Some other stuff in here. Overall rating. So we have a rating for these hospitals. Their mortality rating compared to the national average. Their safety of care ratings. So they have these footnotes. I don't really care about these footnotes. They're kind of in my way, to be honest. Really, it's this below average, above average. That's really the information that's useful here. So I kind of want to return this table, but I want to get rid of these columns that are not useful to me. There's a lot of stuff that's not useful to me. So let's change our query. Here I have a top, we're going to keep the top 100, but let me go ahead and change this to hospital name. Okay, so I've been doing this syntax for so many years now, it's just second nature to me. Do you want to follow along in the in Build SQL yourself, or do you want to just watch the lecture?
I might just watch, but I haven't pulled up.
Okay. Okay. If you need any help connecting, if you want to do that, just let us know. We'll get you going. This is a format of coding that I've developed over the years, and I will make the very strong argument that it is superior to any other format that I've seen before. On the very left side, you have the select. It is all the way against the left side. You have the from all the way on the left side. So let's do the top 100. 1, 2, 3, 4, 5. 5 spaces gets you to here. The first column you're going to return does not have a comma in it, so it goes 5 spaces over, you put in your first column. Then let's go to the next one. And 1, 2, 3, 4 spaces, comma, provider ID. What am I returning here? Here's my hospital name. Here's my provider ID. Okay? Next line. 1, 2, 3, 4, comma, city. Next line. So when I press enter, it's going to take me to this predetermined position. Boy, I'll tell you what, I want to press comma and type in state really bad. I don't recommend you do that. And the reason I don't recommend that is I'm right here on the comma. I'm going to press left arrow. It takes me all the way over. What I'm looking at is a tab. As opposed to right here, there are 4 spaces. Makes no difference, none whatsoever for execution. But if you copy this and paste it into Excel, you'll completely mess up your formatting. Use 4 spaces, not a tab. It'll keep the formatting. It's easy to read when it's in Excel. That's why I do it that way.
Why do you do the comma like in front of
The front or the back. I would say that the bigger experts in software development do the preceding comma. I started off with the far on the right. The reason is, if I want to play around with provider ID, then it is the entire row is provider ID. So we could do this the other way. I'll just do it this way. Okay. So now, we'll go right here. I'll get rid of that. We'll do it this way. Just like that. And we'll bring in my from clause. Just like that. A completely valid statement. Nothing wrong with this at all. So if I want to eliminate my provider ID, there are 2 rows I have to manipulate. I have to manipulate the provider ID row and the prior row. So it's 2 steps rather than 1. Up here, provider ID is entirely captured on 1 row. It's a semantics thing. Do what makes you happy. I recommend the preceding, but it's not a big deal. City, state, zip. And so forth. And let me add in okay. So here I've selected some stuff explicitly, and this star is to give us everything in the table. So I'm going to return these fields plus everything in the table. Well, I don't want to do that, so I'm going to get rid of this. I'm going to get rid of it by putting a dash dash in front of it, a comma, a comment. So that part is now gone. It's irrelevant. That's the same thing as deleting it. Same exact thing right there, but I'm just going to comment it out. Let's execute this, see what happens. We get a restricted data set. Okay. This is easier to read, has more relevant data to me. That's why we did it that way. Okay. So if we look at our data, we have Alabama, we have Alaska. Let's go to 1,000. We have Alabama, there's California, there is Colorado, Florida. We have lots of data here. So I don't want all this data. I want to restrict this down. So let's add a clause. We're going to add where. Again, that's all the way on the left. It's cosmetics. You can do it however you want. State equals AL. AL. Okay. So we have a field. The field is called state. I'm restricting it to the value of AL. Now notice that I put a text string inside of single quotation marks, single tick marks. It's not the double quotes. That's the SQL Server nomenclature. If memory serves, I want to say DB2 uses double quotes. I don't remember. That's what I mean is there'll be slight differences between the different database management systems. SQL Server uses single quotation mark. So I'm going to execute this query, F5. And now, notice we only return 91 rows. Even though I said give me a top 100, well, there's only 91 hospitals in the state of Alabama. By the way, there's fewer than that. Many of these have closed, but that's not our objective here. So a where clause is how you can restrict your data. Okay. Well, I want to restrict this further because I know nothing about Mobile, Montgomery. I don't really know those places very well. I don't want to talk about those hospitals. I can't be intelligent about that. So we're going to restrict it further. We're going to change our where clause to and. We're going to look at the state of Alabama and I'm going to look at the zip code right here. So I'm going to use a function left zip code, comma 3 equals, in quotation marks, in tick marks, 352. Okay. Bunch of things to unpack there. The left zip code 3, that kind of does what you think it does. It takes the left 3 of the zip code. Look at my and statement, and this is where the 5 spaces come from. I said give us 5 spaces from the left because that's a single space, 3 letters, and a single space. That's 5 characters. And so my L on left lines up exactly with everything. That's why I do 5 spaces. Makes it easy to read. Normally when I see SQL code, people do not code it this way. No one codes it this way. The columns will start to shift left and right. And you start to put mental energy into figuring out what are they trying to tell me in this code as opposed to just, this is pretty clean, it's easy to read. Is that question you just stretched? Okay. Let's execute this, F5. These are all of the hospitals in the 352 area code. I'm going to speculate that you recognize a few of those. Do another function. And provider ID in. And so now we're going to put in a list. I'm going to give it a list of 4. So I want to see the University of Alabama. This is UAB. I want to see St. Vincent's. I want to see Brookwood. And I want to see Grandview. I work in healthcare. I know these places. In case you don't know, Grandview is off of 280 near Target. Let's execute F5, restricted to those. Provider ID is a unique identifier for hospitals. And so the rest of this business I actually do not need. So for the purpose of making my future queries easier to write, I'm going to simplify my code by changing my where clause to just be provider ID. Execute. There it is. So, overall hospital score. University of Alabama gets a 2. St. Vincent's is a 4. Grandview is a 2. Brookwood is a 3. Unfortunately, forgive me, I do not remember if a large number is good or a small number is good. I think a large number is good. I don't remember. Irrelevant to what we are doing here. We're going to further analyze this here in a bit. Okay. So, all that to say, SQL is select from where? That is an excellent question. How does it know which are the first 100? Back in the day, when data was held on tape drives, databases were created because databases are extremely efficient on tape drives. Because you know that this particular record, this row of data, if you will, starts on position 1, it ends on position whatever. And then the next row starts on the end plus 1, and it has a distance. And the next one has a distance, a distance, a distance. Literally, a table was held on a tape drive in sequential order. So that tape would spin and it would read the records sequentially, physically sequentially. The top 100 were the first 100 sequential records on that tape, literally. Next, we move to platter drives. In the platter world, the position of the head, there's a head that reads data on the platter as the platter spins around. And so a database, usually, skipping a bunch of details, is held physically in order of how that head would follow that data. So it's the first 100 records on how that platter spins. Then we get to solid state drives. I have absolutely no idea. But the tables, there is a background thing that manages how the tables are sorted, and it will pick the first 100. So roughly speaking, my recommendation is don't get caught up in it. It's just 100 random records. Yeah. I've never used that. I've never tried to tap into that. So I just use it as a sample. Okay. Let's look at another table. Okay, so I'm going to do a top 100 from the table HAI. That is hospital-associated infections. So what happens is I go into UAB, I have a broken wrist, they repair my wrist. I walk out of UAB and I have a staphylococcus infection. I received that infection from UAB. That is a hospital-associated infection. This is a big deal in the healthcare world. So irrelevant to what we're doing here, but that's what that is. Provider ID 010033, by the way, is UAB. Also, I recommend you comment your code. So I made a comment right here that this is data from UAB. If I press F5, it's going to execute my code from row number 1 all the way down. I don't care about this top code anymore. I only care about this piece. So I have highlighted the piece I care about and press F5. This is the HAI data for UAB. Let's take a look. Bunch of demographic data about the facility. So here is what we have. It's a measure and how they compare on that measure. Okay? And so let's look at this measure a little bit more. Lower confidence limit, upper confidence limit, number of days, predicted cases, observed cases, and then here it is. This is the actual metric that I care about. Okay. So these are the way that they calculate this metric. I really don't care about all this stuff. I don't care how you calculate it. I want to know, is UAB a good hospital or not? I just want to see this record. By the way, if we were to really stare at this, we see that HAI1, all this business, SIR. HAI2, all this business, SIR. Okay? What we're after is the SIR. So let's lean on that. So we have our provider ID. Now we're going to go and measure ID like tick percent SIR tick. Okay? So we're going to look at this measure ID right here. And I don't care what it starts with, irrelevant, that's a percent, it's a wild card. It needs to end with the letters SIR. And let's execute that. And what we find is we only get the SIR measures. And so we can see these different hospital-associated infection issues and how UAB compares with the rest of the United States. Okay, so that's a like function. The percent is a wild card. So for example, I want to find HAI3. Let's look for that guy. So I'm going to go percent 3% SIR. So that means give me anything at all, I don't care what it is, find the number 3, give me anything at all, I don't care what it is, find SIR. And that will return only the single record. Okay? So the percent says, give me anything at all, I don't care what it is. A very common way that you will use like is percent, it'd be something like percent Alabama percent. If you want to see all the universities of Alabama, you know, stuff like that, it's usually a percent, your word percent. So you're looking for the word Alabama in whatever it is you're looking for. That's the most common way to use it. In this situation, I knew that the SIR was on the right-hand side, so it's percent SIR. Okay. So we're going to do some math. So we have, we're going to do the provider ID, the hospital name, then we're going to do the average score as score. Okay. So I'm going to pull the provider ID, the hospital name. I want to know what the average score is across all of those HAI metrics. We're going to use a criteria. We're going to grab those 4 local hospitals that we've been working with. I only want the grand total metric. I don't care about the individual components of that metric. And if we try to run this, I'm going to do this because someone mentioned it earlier, it's going to throw an error. So the error is the next clause we have to work with is group by. Group by, and it's going to be these 2 pieces. Okay. So average is an aggregate function. So there's average, there's sum, min, max. You can get a standard deviation. Anytime when you're taking multiple rows of data, you're taking those multiple rows and putting them together, such as a sum or an average are the 2 most obvious kind of ways you can do it, min, max, whatever. You've created an aggregate function. Well, how do you want to aggregate those numbers? Well, I want to aggregate it by the provider ID and the hospital name. And so that's what the group by statement is saying, how do I want to combine these together? Let's execute this, see what happens. What we find is we get the 4 hospitals and we get the average score. So that's taking those 6 HAI or however many numbers it was, all those HAI number statistics and average them together.
Does it matter which order you do the group by? Like if you did hospital name before?
Absolutely it does. So in my entire life, one time I have done a group by that was not identical to the select statement. Every single time you do a group by, take all of the all the fields you're using in your select, Control C, copy, go to your group by, Control V, paste. Every single time. I've not done that once. It was a complex, weird thing I was trying to do. It is always the same thing. By the way, I recommend inside of your select statement, have all the fields you want to select on at the top, and then end with all of your aggregates. Why do I recommend that? Because you can select these, press Control-C, copy, go down here, Control-V, paste. You're done. Okay? So the order absolutely matters, but it's very simple. The group by is identical to your select, basically every single time. I'll give you a way that that fails here real quick. This hospital name. It's kind of long. I don't like to read that. I don't want my column heading to be that long. So I'm going to rename this. I'm going to name this as hospital. So I'm renaming it. Whatever this returns, it's going to return hospital name. I'm going to rename it to the word hospital. Okay? So let's just execute this, see what happens. Look at that. It's been renamed to hospital. Human readable. I like that. Very useful. Okay. So let's deal with the group by. Let's grab my select, Control-C, copy. Let's put it into the group by, Control-V, paste. There it is. Copy, paste, identical. Let's execute. And it fails. By the way, if you get an error, double-click the error. It'll take you to where the error is. You cannot rename fields inside of the group by. So when you do your Control-C, copy, Control-V, paste, just get rid of your renaming. That's the only thing you have to do. Just like that. And then you're back to normal querying. Have you ever had an experience where you used a different group by than a select? You have. I'm curious. Is it easy to explain?
Well, I mean, I was thinking in terms of computer coding, right? Start from the top to the bottom when you run a execute a, you know, some kind of script, whatever. It's going to start from the top and go down. So now, you've already named it, you've already renamed it. I mean, so when it goes down that list of steps, it's going to hit that. It wants to look for the word hospital, not hospital name.
Yeah. All right. All right. Let's get fancy. This is, I've said I've written this thousands of times. Select top 100 star from dbo.hospitals. And I have a provider ID. Right here. Okay. Now we're going to grab it from deaths. From the provider ID. Let's look at the death table real quick. This is the UAB death table. So we have all of these metrics, and we have compared to national average. And so all of this stuff is really good. I want to make our lives easy. We're going to look at heart attack deaths. We're going to look at this. Okay? So that's the death table. Whoa. This is our 7 o'clock time point. It's when the projector shuts off. It is, by the way. Yeah, it's a physical thing. I thought I had to use the remote, but it's a, yeah. There we go. Okay. So let's look at the HCA HPS table. And that table looks like this. And importantly, we have this measure ID of the star ratings. Let's look at just the star ratings. So star rating. What did I do wrong here? I don't know why that didn't work. It's fine, we can move on. So the star ratings for hospitals, this is patient-reported data. You go to a hospital, and they give you a survey, and you rate your experience. So the topics are bathroom cleanliness, nurse communication, doctor communication, and so forth, okay? So here's the thing about that. This has nothing to do with SQL, it has everything to do with healthcare. Patient's experience in a hospital is completely unrelated to the care that they get. So how clean is your bathroom? I really don't care. Did you get a hospital-acquired infection? I really do care. What was the communication of your nurse? I really don't care. Did you leave here cured? And so the star ratings are kind of a misnomer, kind of a not really good way to measure a hospital. However, it impacts, I apologize, I just checked that because of the front door. It impacts the reimbursement the hospitals get. And so hospitals have invested a good bit of money into impacting these ratings. And they invest that money in two ways. One is to do what the rating says, which is what CMS's goal was. It's not useful that they do that, but they do that. The other thing they do is they invest into ways to manipulate people's opinion. For example, before we give you this survey, we could give you a pre-survey that says, what do you think of your experience? And if your experience was really good, we redirect you to the survey. If your experience was bad, we redirect you to a, let's talk about this first, see what we could have done better before we direct you to the survey. Okay? So star ratings are completely manipulated. They're useless, but they are hugely important because they impact revenue. Has nothing to do with SQL, but now you know my opinion of star ratings. So let's do a big execute. I have 4 different tables right here. F5, execute 4 tables. We get an error. Where did I get my error from? Oh, I know why. It's because of this business. Whatever I did wrong here. Get rid of that business. Right here, 4 tables, F5. Boom, boom, boom. Here they are. Here's the first table. Here's the second table. Here's the third table. Scroll down, here's the fourth table. So you can run multiple queries at the same time. That's what my goal there was. Okay. Now, so the downside to what I've done here, let's look at this first table at the top. Provider ID, hospital, address, city, blah, 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 blah. The second table, provider ID, hospital, address, it's still the same for UAB. It's all the same for UAB in the third table. It's all the same for UAB in the fourth table. I'm getting a whole lot of redundant data here that I really don't care about. So I'm going to simplify this down. I'm going to do this quickly. And I'm just going to copy my code. So I could sit here and type it, but let's just do it. Here it is. So I'm going to highlight my code, F5, execute. Okay, first table. The first table is my hospital table. This explains who am I talking about. Who I'm talking about is UAB Hospital. They're located in Birmingham. They have an above average national rating. What's my second table? My second table is from the deaths. By the way, their acute cuts and tears from medical treatment has this particular score. What does that score mean? I have no idea. I don't care. But I've pulled a second table of data on UAB. The third table is from this HCA HPS. This is that star rating system. Their overall star rating for UAB is 5. They get extra reimbursement. In the final table, we're going to look at hospital-associated infections. They have some sort of score. Again, I really don't care. So if I wanted to make a profile of UAB, I've executed 4 queries. I can copy the data into Excel, and I can put them together. That's fine for one hospital. There's 6,000 hospitals in the United States. That's not going to work. The simplified, great question. Great question. Okay. I did a top 100 star. Give me every single field in that table. All of it. But I don't want to look at all of it. I want to look at this much. So a simplified view, my human interpretation of what I am doing is I'm going to call simplified. And rather than do the star of return everything, I'm going to return this smaller set of data. So there's nothing magical that's happened. I just typed out the fields that I actually care about rather than all of the fields. That's all I did. And my purpose in doing this is to get to the point of saying, I want to combine these 4 tables together. That's my goal. So I said in a relational database, for example, my rental property database, I had a table for owners, a table for renters. I kind of want to link those together. So the 2 most powerful things in Excel is VLOOKUP and pivot tables. The most powerful thing in SQL is a join. So it's equivalent to like a pivot table, if you will, in usefulness. Very powerful. That's the whole purpose of a relational database. So let's talk about joins. Talked about this table. We have an owner table and a renter table. In some way, these things are related, obviously through the address. So I want to, all I've done is the exact same table. I'm putting it in a human form so it make it easier to talk about. Obviously, Avenue North on the owners is related to Avenue North on the renters. Those are related. Well, I have a person who owns Brook Cove, but Brook Cove has 2 renters. So I have 1 owner and 2 renters. So it's a one-to-many relationship. Those are related. I have 2 owners and 1 renter. That can happen. And then look, I have a renter, but I'm missing data. I don't know why I'm missing data, but I'm missing data. So where did that go? And I have a facility that we own, but hasn't been registered in the renter's database yet. So I don't know where that data went. But even though I have problems with this data, I still in some way want to combine it together. So we're going to use a left join. And this is how the left join works. We're going to say that the ownership table is legit. That's the data we're going to return. I want to see these columns on the ownership table. But based on the stuff that exists in the ownership table, I want to know who the renters are. So I'm going to take the Avenue North status rented. I want to pipe that over to my owner table and link those together. Well, I have 2 renters at Brook Cove. So I have to duplicate the ownership data. So I have 2 records of ownership data, and I can link in my renter data. So I'm going to duplicate it. Well, in the other situation, I have 2 owners at Crosshaven, so I'm going to have to duplicate my renter data. Combine them that way. Okay? And then forget the Druid. I don't care about that because I'm interested on a left join. I'm interested on the left table, the owner table. The Druid data doesn't go anywhere, so just forget that. And then, but I want to retain this Elm data. And so the end result is going to look like this. We've combined together Avenue North. We've duplicated the Brook data. We've duplicated the Crosshaven data. The 4000 series, Druid, I kicked it out. That was useless to me. The 5000 series, the Elm data, well, my linkage is, it's not there. It's null, N-U-L-L. It's a key word. So it's linked to null. It's there, but I don't know what it is. Okay? That is a left join. We've taken the 2 tables and put them together based on the table on the left. There it is. Okay. Okay. So let's look at the from clause. I'm going to start by saying, define my left table. It's DBO hospitals. And I renamed it. I can forever call this DBO hospitals, or I can just rename it. I renamed it hospitals. The most common renaming you will find will be either A, the letter A, or it'll be HOS. Okay? I see this pervasive. Everyone does it. It's so easy to type the letter A. So many fewer keystrokes. I'm going to left join it to the deaths table. I'm going to call that deaths from now on. Most common form I see is B or DEAT or something like that. Some sort of abbreviation. Don't do that. Yes, it takes me a lot more keystrokes to type the word hospital. No question about it. Okay? But when you read that, you know exactly what it is. When you see it called A, which was it on table A? Yeah, I've seen it go way down, G, M. So, you know, you're linking table G to table B. How are these tables linked? I don't remember. And so you use the acronyms, HOS. Like, okay, is that hospital or is that HOTS? Or what is HOS again? Just write it out, okay? Save yourself a lot of headache. So we've joined, first 2 rows, we've joined hospitals to deaths. Now, how are we going to join them? There's lots of ways we could connect these tables. So going back to my PowerPoint for a moment, I could have tried to connect these from owner to status. So I have a owner of Adam, my status is, I don't have an Adam. That's a null. Doesn't link. I could have done that. That's dumb, but I could have. How are you going to link these tables? I chose to link them by address and address, the logical way. The way that I'm going to link these tables is by saying I want to link them if the provider ID on the death table is equal to the provider ID on the hospital table. That's the logical way to link these two tables. The most common linkage you're going to see will be key, K-E-Y. Okay? So it'll be like the hospital table links to the address table by, on the hospital table there's address key, on the address table there's address key. And you link the keys together. That's the most common linkage you'll see. There's lots of ways to link tables. In this case, we're linking them through the provider ID. We're linking by provider ID because provider ID is unique to each hospital, not duplicated by hospital. So that's a left join. With the left join, you have the on clause. That's what I'm trying to say. Let's return some data. So from the hospital table, I want the demographics of the hospital, the name, the provider ID, city, state, zip, ownership, all this business, even the overall rating. And this is just stuff from the hospital table. How do I know it's from the hospital table? Because I predicated it with hospitals dot. From the hospital table, I want the zip code. That's what that's saying. Okay? So these are the fields I'm going to pull out of the hospital table. Then from the death table, I want this measure name, and I want the score from the death table. Okay? We still need to do the restriction on the where clause. Well, I restricted based on the provider ID. As a side note, notice I restricted on the left table, leftmost table. And by the way, within the deaths table, there's only one measure I care about. There was, 15, 20 different measures within deaths. There's only one I care about. If I don't do that restriction, I get one hospital and 15 records. So I'll have 15 times I'll have this data. Maybe that's what I want. I don't know. But in this case, all I want is I want the hospital and I want a single measure ID. Just one row. Let's look at it. Okay. So this is all stuff from the hospital table right here. All the way, the overall rating, the national mortality, national comparison, the safety of care, and then these last two fields are from the death table. That's that single metric from the where clause on the death table. If I didn't put in that metric, I'd have 15 rows. Let's look at that. Let's do all 15 rows or whatever it was. I'm just going to not highlight it for my execution. Forget that part. F5, execute. Here's the 15 rows or however many it is. And here's the hospital table here on the left. Notice this is all duplicated. It's duplicated because there's only one hospital row. We had to duplicate it because we have multiple death rows. Go to the right. Here's all my death rows. All those differences. I didn't want all that data. So we just executed the single row. Okay. Let's get fancy. Okay. So, previously we joined two tables together. Now we're going to join four tables together. The way I want you to think about this is you have a particular table and you bring in a new table. Stop thinking about them as two tables. Once you've linked them together, you have one table. You link in another one, you have one table. Another one, you have one table. Okay? It's just one absurdly long table. If you think about it, if you put in your mind, if you have all these different separate pieces, you're going to start to lose it. So the way we do the connection, here's my leftmost table, hospitals. Okay, one piece. Let's go to the next one. Boom. We're going to connect it to the deaths table by the provider ID. Okay, so now they're connected. You have one table. We're going to connect it to the HCA HPS survey, star ratings. Just connect in that one piece. Connect in the HAI table, one piece. Okay? So just put in your mind that as you put this together, it's just one table. So I've connected 15 tables before. It becomes unwieldy, but if you just think of it as one, it's pretty easy what you got.
So is it connecting all those other tables you're connecting to the hospital table?
Good question. Okay. So this first table, we have the hospital table. It's right there. Now we're going to connect the deaths to the hospital. And the way we do that is by connecting right here, this row, deaths provider ID equals hospital provider ID. And so the deaths linked in to the hospitals. Now we're going to bring in another table. And the way I'm going to bring in this other table is HCA HPS provider ID is hospital provider ID. I went back to that original. I did not have to do that. I could have connected it there. Makes no difference. So you can chain connect them, this one to this one to this one to this one, or I prefer to bring them back to the beginning as much as I can. It's a preference. I'm under the impression it'll run faster. I could be wrong. I don't know.
So what if you had like all those are connected based on the hospital ID, but say you had like 3 tables that are connected based on that, and then one table relates to another table that connects differently, doesn't connect.
The overall, I would recommend that as you bring in each piece, stop thinking of them as individual pieces. Just think of it as a single unit. Absolutely, I have a situation at work where I do this, where I have my claims data, my sales data, whatever, and then I bring in my account. My account is related to my sales data, but then I need to learn more about my account. I need to know who my account is affiliated to. So my affiliation goes to my account. That's that. Then I come over and I'll pull up the address. Well, the address, well, address, bad example, the price list. The price list is related to the sales, but so the linkages start to get wonky. But just remember, as you bring in each table, the end result, so when I get to my second point right here, that is one table I have now. It's not 2, it's 1. It doesn't matter where you connect within it. I could connect to the deaths part of this table. I could connect to the hospital part of the table. Makes no difference. You always have to have a commonality. Correct. Correct. And so what happens is 2 is related to 1, 3 is related to 2. And so you can do 2 related to 1, 3 is related to 2. That's fine. You can chain it that way. You can also go 2 related to 1, 3 related to 1. Any way you want to do it. Really, side note, this will blow your mind. Don't worry about it if you don't get it. So you have 2 related to 1. You have 3 related to 2. The most efficient way to write that is 3 related to 2 and 3 related to 1. But whatever. That's a whole nother discussion. That's about the optimizer and speed. And anyway, any way they link at all. They can link to the base, to the second part, the third part, anyway. All right. We have 4 tables linked together. Let's look at our where clause. On my leftmost table, I've restricted it to UAB. I only care about 1 death factor. I only care about 1 star rating factor. I only care about 1 HAI factor. Let's execute it. Let's look at the where clause while it's running. Here's my hospitals from the hospital table, from my death table right here, from the star rating table, from the HAI table. So I'm pulling 4 different metrics, 4 different areas. This is all from the hospital table. We get the national average stuff. Then we get the death data. then we get the star rating data, and then we get the HAI data. Okay.
Duplicate rows in the order in which you list out your join statement. So like,
The duplication is not so much related to the order, it's related to the quantity. So what happened, by chance it was in order, what happened is when we connected these, hospitals was one row. Okay, let's try that again. That's not true. This says hospitals is one row. And that's going to connect to all the UAB rows, all 15 rows on the death table. But I said, hey, I only want one death row. So now the hospitals and death, that piece combined, is now going to connect to the star ratings table. And there are 6 star ratings. But inside my where clause, I only want one. Okay? So this chunk is now going to connect to the HAI table. HAI table has 6 HAIs, and I'm going to connect to all 6. So what happened was I didn't restrict this to 1. If we had only done the first 3 tables, it would have been a single row. But because this restriction, there's 6 star rating, 6 HAIs, it returned all 6. But we can fix that because we did the aggregate function previously. So let's do it again. So do it that way. I want to comment this row out. So I could come right here and do a comment just like that. Nothing wrong with that. I could come right here and comment it that way. Nothing wrong with that. Or I can click anywhere on this row and press that button. By the way, it's very useful if you want to do a bunch of rows at once. If you want to undo it. So it's just a little bit faster. I'm going to click on, I want to get rid of this one. It's now gone. Why do I want to eliminate these 2? Because from the HAI table, I'm getting 6 rows. And I only want 1. So I want to do an aggregate function, an average across those HAI rows. And so if I return all 6 rows with this line right here, and I do an average, well, I'm still returning all 6 rows. That's not what I want. So I knocked out this HAI measure, this HAI compared. So I'm only returning one piece from the HAI table. It's going to be an aggregate function, an average of the score. We need to do a group by. So I'm going to grab my entire select clause from where group by, paste your select clause, identical, same order. If I execute it, it's going to fail. Why is it going to fail? Because I've done renaming. Get rid of the renaming. Just like that. It's identical to the select clause. And now we can execute. Ooh! What did I do wrong? What's wrong with that? Good question. It is not within the average function. It's taking the entirety of the average function and renaming it. And I'll show you what that looks like without the renaming in just a moment. Oh, it is within the function. Good call. Good call. Execute. Okay, so the first 3 tables were single row, single row, single row, and now we're doing an average on the 6 rows of the HAI, and so that collapses down into this average score. That's meaningless, by the way, but that's how you do it in aggregate. So most importantly, we have this complexity of these linked tables. Forget it. It doesn't matter. Once you've linked them together, it's a single table. That single table had 6 rows. We ran an aggregate against those 6 rows. Okay. Okay. All right. So in talking about these joins, we have this leftmost table, and we're linking things to the left. Okay, so we're saying the leftmost table is data we're going to work with, and then we can connect things to it. There's nothing special about that left table. We could do a right join. It's the exact same thing as the left. Works the exact same way. So over here, we have 2 renters, 1 owner. We need to duplicate this data. Oh, I put my arrow here wrong. I'm sorry. We have 2 owners, 1 renter. We need to replicate the renter data. We're going to retain this renter data because we're doing a right join. And I don't care about this because that's extraneous. What I care about is my right join. Looks like this. Importantly, that Druid gets nulls, and that 5000 series is gone because we're doing a right join, not a left join. I have 1 time used a right join. It was because I executed a query, long query, with a left join, giving my data, that wanted the same thing on the right join. And so I could have taken my tables and moved them around and all this. I was like, oh, just change the word left to right, execute. 1 time. That's it. So I don't particularly like right joins. Full outer join. So this is a good one. Okay? So if you're going to do a full outer join, it says, look, I have this owner table. I know the people who own the properties, and I know the properties there for rent. And so yeah, there's some holes in my data. I don't know who owns the Druid facility, but I need to recognize that. I mean, that's in my data set. I don't know who's renting Elm, but the building exists. You can walk to it. So I want to retain everything. I want to do a full outer join. If it's in the if it's in the owner table or it's in the renter table, I don't care. Give me everything. When we do that combine, look at your nulls. So I have a renter and no owner. I have an owner, no renter. I have the duplication of the data when we have multiple people. Gives me everything. Full outer join gives me everything. Rather than say left join, you say full outer join. It'll give you everything. Won't chop anything at all. Maybe I care about the inner join. So I only want good data. I'm trying to match people up. I want to know who's matched. So this Druid thing, I don't know who the owner is. Just forget it. I mean, I can't match these people together, so we're just not going to bother. Throw it away. This Elm thing, I don't know who the renter is. Throw it away. Rather than say left join, you say inner join. And it will only give you the places where there's a match. It'll create the duplication. You'll do the duplication. But if there's a null, it just throws it away. So here's all the intersect, the inner joins. Okay. All right. I have 24 minutes left. So that's the SQL, the pure SQL I wanted to work with. It's select from where. You can do aggregates. To do that, you need a group by. There's joins. I use left joins very heavily. I rarely, but occasionally, will use inner and outer joins. Basically never use a right join. But that's all we're doing is we're just building our data set. And then you use your where clause to restrict it down. Okay? There's a tremendous amount more to SQL than all that. But that's a good starting point. Now, I have some other topics about how to get data into a server, working with tables inside of a server, stuff like that. So we can get into that kind of stuff. But before we do that, I wanted to stop right there to say that's the select from where that I wanted to talk about. Questions, thoughts, comments? Nick, you're brilliant. At least someone laughed.
In terms of what SQL is capable of, I know that you were using averages. Can it do pretty complex calculations within there, or is that where you have to start utilizing
SQL can do pretty much anything Excel can. I highly recommend you don't do that. In Excel, you can do a complex function very simply. In SQL, you'll have to do it one step after another, after another, after another. So it gets to be very complex and not recommended. But it can get much more complex.
Is there ways to restrict what people can be doing? Like if I wrote a code, Billy Bob comes and deletes the character, and I can't find it back. Can I?
So yes, it took me a shocking amount of time to give you guys full access. It was one. It took me a lot of time to actually took me a long time to actually get a server. And I loaded it up, and then I created these 12 accounts: BhamQuants 01, 02, 03, 04, and it gave you access to nothing. And then I had to research how to give you access. I gave you access, but it was like read-only access. Like, well, I want more than that. I had to figure out how to. It was a shockingly difficult thing to give you full access. But there is a lengthy list of permissions that can be given or removed. So in your company, the most logical thing is you will get the select permission, which means that you can query data, you can return data, and that's it. That's what I have at my office, so, which is correct. I like that. I don't want any more than that. They can give you the delete function. They can give you the create function, the drop, the insert. You know, all these different little functionalities they can provide you. For the most part, the people in this room are going to want the select, and not so much the others. There's a situation where you can get your own personal workspace. You can create your own tables. I highly recommend that. There's some hiccups in doing that. They're IT related. Your IT department may or may not care, but it's very useful to have your own workspace. But giving you select should not be an issue. They may not want to, but there's no harm in it. The harm comes from you write a wonky query, and it'll do two things. One is it'll take up server time attempting to execute it because you've done your linkage wrong. So, for example, I linked on provider ID. What if I linked on above average ranking? So I have 2,000 facilities of above average ranking linked to 2,000 facilities of above average ranking. So 2,000 times 2,000 is a 4 million record match. The server can start to spin. Now, there are restrictions placed by the DBMS that will prevent you from shutting down the company. So you cannot do that in any situation. And so although you are burning resources, you're not going to damage things. You're not going to shut down customer service or anything like that. IT may yell at you, rightfully so. The second thing that can happen is it does the 4 million cross and then attempts to push it to your computer. And so your network bandwidth now has this huge chunk of data that's trying to come to you. So then someone else in your company, I have seen this happen, someone else in your company is going to their network drive trying to copy a file down, and they can't get it. Why can't I reach my data? Well, it's because you have this junk that's trying to come to you. So those things can happen. But for the most part, your IT department will restrict you down to not doing damage. So. Should be. Single source. So that gets into an interesting conceptual issue. The way a company should be set up, and I'm amazed at how few companies are set up this way, is you have a production database. And production is the single source. That is the facts. You give that to your auditors. You give that to the government. You use that in your financial records. That is the source of data. From the source of data, production, they then create a test environment, which allows you to go in and mess things up. Very useful thing. Also from that source, they should create a reporting environment, which is far easier to query. So I'm doing all these table joins and whatnot. In reporting, they do that kind of stuff for you. It makes it very easy to query it. You can query it very fast, but it's not as reliable as production because those linkages exist for a reason. And so this is up-to-date, very accurate information. This is probably correct. Probably correct is not good enough in certain situations. In most situations, it doesn't matter. And so they'll create this third environment for you to do reporting from.
So I have a question as it relates to that, because I'm dealing with this right now. We have, one of my clients has a smaller company, but they're using an ERP CRM system that's way more than what they needed.
Yeah.
Just short of Oracle.
Yeah.
It's this Navision, and I can't remember what the CRM is, but it's all Microsoft, right? So they brought me in and said, okay, we've got all this stuff, and what I quickly realized is that we've got all this data that they're not even scratching the surface.
Yeah.
Using, right? And I mean, not even from like this data that they bolted on this reporting tool that's
Yeah.
not easy to use, and they needed a dev just to get that working. And so my first thing was, well, wait a minute, I have this thing over here called Power BI.
Yeah.
So I started digging into that and realized, well, oh crap, not only can I overlay this, I can also save them a truckload of development costs.
Yeah.
So we're in the process of doing what you just described. I've never heard it described like that, but our production database is what Navision kicks out.
Yeah.
Right? We don't touch it.
Yeah.
And back to what you said, those permissions,
Yeah.
Well, what we decided today, actually, it's funny you bring that up, was that the IT person was asking if I wanted access to that, what you call production data. And I thought about it, and I said, actually, no, I don't.
Correct.
Because I don't want to go in there and accidentally botch something.
You have two issues why you don't want to touch production. One is you don't want to botch it. Number two is you don't want to burn up the resources.
Well, and the other thing, the third for me, because I'm a finance guy by education and experience, and what you just said, and I didn't think about this, was from an auditing perspective.
Yeah.
If I'm a CFO, I want that to be
That's it.
my Bible, right?
Yep.
So that's something I had not thought about until you just said it. So that even furthers what you were just talking about. I was more worried that I was going to mess something up. In reality, it's bigger than that.
It is.
And so what we're creating is and what I would call too a test environment where we're
Yep.
pulling everything into Power BI before we're just connecting to the tables, loading the data, and then we'll tinker in Power BI to get it to where we want. And then, something else you mentioned that, my background is more financial modeling, so Excel is kind of where I start to cut my teeth, is,
So to start with, you're talking about data loader, which is a option you may want to consider. I do want to mention, I think of data as having three functions. There is extraction, and there is no tool more powerful for extraction, with a few minor caveats, than SQL. There's analysis, with a few minor caveats. There's no tool more powerful than Excel for analysis. And then you have presentation, and there is multiple options for presentation. There's no clear winner to that. But SQL to pull your data, Excel to analyze it. There's nothing more powerful, virtually nothing more powerful than doing that. Now you talk about using Excel to clean it. So Power BI, Tableau, they have data cleansers to do a cleaning process like you're talking about before it goes into those tools. That's going to be a better option than swinging it through Excel. But conceptually the same thing you're doing, it's just it'll be faster.
Yeah, I'll be the first one to tell you, I think of how do I get to my end result.
Yeah.
And so I'm thinking creatively, how do I automate this reporting? And a lot of it has functions built into these reporting, and that's how I got, they called me in because they needed some help, with these pretty extensive Excel, financial modeling stuff for like their salespeople commissions and stuff. It was just random stuff, and I got in here and I'm like going, well, wait a minute, this can be automated. So I'm a rookie to BI. Like this is my first week to really like look into it. So I haven't even scratched the surface on, I understand the visualization part of it, but for me, I'm just trying to get to the quickest solution, right?
Yeah.
And all of our SQL stuff is already set up, but I've had to learn that on the fly. It's been years since I looked
Yeah.
at it because in today's world, it's so much. You've got IT departments that do that for you, and it's spinning up a AWS database. You have to pay them a ton, but it's really not what it used to be when I
Oh
did
yeah.
that stuff years ago. So it's interesting you brought that up because I'm feeling that just today.
I guess, I'm a bit naive on this side. I'm accountant by trade. I've been learning about all of this, but we're talking about production, data being the ERP system. You mentioned the CRM, so SQL will help join the ERP data and CRM data. Is that the impacting part?
I haven't gotten there, but this presentation just helped me visualize how we would do that for them. I know what, a unique identifier there is that we could use. So, and it's for us, what we call our customer number.
Yep.
But that's why I came here was to
Totally forgot about that.
figure out how to do that myself. And then, my background is accounting. And so, this is still new to me, and I haven't had to.
I'm going to steal your pen.
So, yeah.
Or better yet.
For me, stay tuned. I'm learning too. But
Yeah.
yes, theoretically, that I needed a refresher myself because I haven't had to do the back end.
What I would say to that, you mentioned a CRM and all that, is SQL, well, the database is where the data is stored. SQL is going to interact with that data.
Right.
And from there, that's going to pipe into a CRM. And that's where you're going to get your power from. But SQL is the backbone that runs all that.
Right. So explain that though, because I was thinking, I thought you were asking the same thing I was, which is extracting data from the CRM and combining it with the ERP, because those are in two different.
That would very commonly be SQL as well. But at
that's what we use the SQL
yeah.
Server for everything, because it's all.
So Oracle is a composite of thousands of tables. This is the base Oracle application. They give you thousands of tables. And so it has, for example, a CRM built into it. That CRM is composed of dozens or hundreds, I don't know how many tables, holding all this data. And when it moves data between those tables, it's using SQL to do that movement. If you load data, it's using SQL. It's using SQL to do that movement. But at the end of the day, when your Salesforce goes out and wants to pull something up, they go into a website and they click, I want this customer. It executes a SQL statement to all that business that's happened in the background and returns it onto the web.
So you're saying it's clicking and pulling.
Yeah. But SQL is the underlying side. So your sales team is going to be the point and click on the website. But this is the back end. And the significance is we talk about Excel, which is good for so many thousands of rows of data. Well, we could have millions of rows. So one of these files, when I was trying to load it into the database, I accidentally double-clicked it, and it was over 1 million records. And so Excel threw the error message of, this is too many records. Of course, it dogged my computer, all this kind of business. And so SQL fixes that because it doesn't care about that 1 million. 1 million is nothing to SQL. But the point-and-click method works for small data sets, but SQL is when you need the real powerhouse, the millions of records powerhouse. My typical database I work with every day, it's actually, in my mind, a rather small database, has 20 million records in it. And so I'll hit that 100 times a day. And the point there is to take the 20 million records, break it down to 10,000 I care about, put that into Excel, analyze it. Make a friend in IT. A lot of this I learned by doing that. I'm curious what you guys think about, so the server here, like I said, it's up for about 3 weeks, and then I'll kill it. I'm curious what you guys think about that. If you want to play around with it, I can show you how to load tables into it. I can show you how to create tables, drop tables, stuff like that. If you want to play with that, let's do one. This is a server. This is a database. These are tables. We're going to go to the database and add a table. So let's go to the database, right-click, tasks. You have a choice. You can import a flat file, or you can import data. If you import data, it's going to bring in, roughly speaking, an Excel file. Many more options than that, but for our purposes, it's an Excel file. The downside to that is you have to have certain software loaded onto your computer. Software is kind of a pain in the butt to deal with. I was unable to accomplish that task in 30 minutes last night, and so I'm going to show you how to load a flat file. A flat file is a CSV file. Here we go. What file am I going to load? I'm going to load CMS in my data set. We're going to load in a timely and effective care file. You can get to that file from the website if you want to get to it. We're going to give it a table name. I highly recommend you have no spaces in your table name. Okay? Ignore the schema thing. Discussion for another day. So it's going to preview my data. The Excel-based version, the load your data version, will give you a better preview than what we're about to see right here. This is a top 50 rows of data, and this is showing me what my table is going to look like. Okay? That's fine, I don't really care. I'm going to hit next. Here's all of those columns, and here's SSMS's suggestion on how I format the columns. It's saying all of these should come in as a char, in varchar, a string character format. So here's the problem. I have hospital name is in varchar 50. By the way, I have a hospital name that's 81 characters long. I'm not going to tell you how long it took me to figure that out. So if you attempt to put an 81 character name into a 50 character field, it will throw an error. It's not going to load your data. So what you need to do is go in here and change this from 50 to 81. Okay? How do I know that was 81? A lot of work. A score. It says the score is in varchar. That is not an in varchar. That is a numeric column. That happens to be either a float or a numeric. A numeric. This is going to be a numeric of size 13. Gosh. 13 with 3 decimal points. 3 decimal points. So this can be 10 integers and then 0.123. So 10 numbers, then 0.123. How do I know that's 13? Took me like 20 minutes to figure that out. It was way too much effort.
So is this considered double precision variable or N64?
That's a very good question. And it's going to depend on the implementation of your RDBMS, both by who the manufacturer is, Oracle versus SQL Server, and by the version number. This is SQL Server 2016, which is going to give me much larger number sizes than prior versions. You'll have to look that up by system. So anyway, you can change your data type. If you load this from Excel, it will do this in a much better way. So that's why I wanted to mention that. And then I want to say I can click Next without this blowing up. It's going to do this. Do you want to do it? You hit Finish, and it will create that table for me. I don't want to create that table. But you have to figure out that invarchar thing. My recommendation is set these to be like invarchar. For our purposes here, I'll just say 500 and do that across the board. So do this, like this, and it'll get your data in there. There's a lot of problems with doing that, but for the purposes of a beginning class, just do it and it'll work. Okay. That's how you load data in. Last thing I'll mention. Select everything from dbo.hospitals, okay? And I'm going to select that into dbo.nick-is-cool. Select top 100 because I want to get this done. We're running out of time. And if we do that, it will do it. Where's my table? I don't see my table. Okay? This is a stupid thing. I don't know why we have to do this. Collapse that down. I don't know why you have to do that. Hit refresh. Open it up. There's my table. Your favorite function. Drop table. Nick is cool. It will absolutely drop your table. Refresh. It's gone. Go ahead.
Is there a way, like if you have like a million tables, you don't know which table it is in, but you know the field you're looking for, can you like search a field and it'll point you to the table? Like you know the column name.
Don't have it at my fingertips. Yes.
There's a way to.
Yes. Search the internet for it. What you have to do is you have to write a specialized query. So I've shown you 4 tables that I created. Okay. There are hundreds of system tables that do stuff in the background. What you have to do is query these system tables to return every table you have, every column you have, and then you can use a where clause to figure out what you want. But you run that through the system tables. And there's a query that does it. I don't have it at my fingertips. Yeah. All right. There's a ton to SQL Server, an amazing amount more than what I've shown you today. But select from, where, group by is my biggest takeaway for you. The servers are out there for the next 3 weeks. If that's a deal and you want that more, let me know. We'll make something happen. If you have questions about SQL Server or really SQL in general, I'm happy to help you out. Send me a message. So that's all I got. Did you sign in? I see that may have stopped right there. Okay, perfect. Wonderful. All right, that's all I have.